So, good afternoon, ladies and gentlemen. Today we are going to start our next lesson, and today the subject of our lecture is devoted to the ST PLC programming language. ST is structured text. It's one of the well-known PLC programming language. So, the main topic is ST language is an expression language. Each expression in our program ends with a symbol semicolon. So the result of expressions assigned to variables using the symbol, as you see, this symbol. So the expression is a construct that returns a specific value after it has been calculated, and next rule is the expression consists of operators and operands. An operand can be a constant, variable, function block, or other expression. So we see there are some expressions which can be used in our program. So it can be like this, or like this, or like this. So this is the common view of programming ST language. So the calculation rules for ST language. Expressions are calculated according to the priority rules. The operator with the highest priority is executed first. It means that expressions with the highest priority will be calculated first, and the operator with the lowest priority is calculated second or last, and so on until all the operators are executed. Operators with the same priority are executed from left to right. This is the main rules when we programming PLC in this language. So the following table lists the operators in order of priority. Yes, the list below shows us the priority rules of each operators and expressions. So bracketed expression, yes, if our expression in the bracket is this is the highest priority. This expression will be calculated first. Then function call. If we call some function or function blocks, it will be executed second after expression in the bracket. Exponentiation is this operation has a third priority. Then the replacement of the sign or numeric extension will be calculated. After that, ST language will be calculate multiplication, division, absolute value. This is the all algebraic expressions. Then addition, subtraction, comparison, and last will be executed all logic operations. Yes, as we see, logic and will be calculated last. logic AND has the lowest priority. Yes, this priority rules must be used when we programming PLC in this language. So assignment operators, yes, this is the one of the main operators. Assignment operator, we're using this symbol. Yes. For example, variable 1 assignment to this expression, as we see, and every expression will be separated by semicolon, as like this. So, function block calling. How can we assign a function block in our program? A function block is called using the name of the function block instance and a list of input parameters with data assignment in parentheses, as this. This is the function block name, and this is the input parameters. Yes, as we see, this is the assignment operations to inputs of function block. And second expression is shows us how can we assign to the variable a output of this function block. So as I said, the following example calls a timer with the inputs in and pt. The value of the output variable q is assigned to a variable a. So next, one of the main operator is empty expression. Yes, empty expression. If we programming PLC by STL language, our program at least must contain semicolon. Yes, it means that our program has an empty expression. So this picture of common view of the program in STL language. So next operator, it's instruction if. Using this instruction, you can check the condition and perform some actions depending on this condition. What does it mean? This is the syntax of this instruction. Part of the construction in curly brackets, it's optional. This is the optional. Yes, these brackets contain some optional expressions for this operator. So, if Boolean expression 1, this is expression, returns true, then if instructions will be executed. This is instruction will be executed if this expression will be true. Otherwise, the rest of the logical expressions will be executed one by one until one of them returns true. Then, the instruction that follow this logical expression to the next else if or else are executed. If all logical expressions are false, the instruction after else are executed. So that means this is instruction will be executed if all these expressions will return false. So this is the example. How can we use this instruction in our STR program? So next, one of the main operators, it's instruction case. You can use case instruction to map different instructions to several different values of an integer variable. So this is the syntax of this instruction. If the variable var1 has the value I, the instruction I statement is executed. So variable 1 is this. If this variable has this value, this instruction will be executed or calculated. So next, if variable 1 will have this value, next instruction 2 will be calculated. So in order for the same instruction to be executed for different values of the var1 variable, you must list this value separated by commas as this. So in order for the same instruction to be executed for an entire range of values, you must specify the start and end values separated by 2 dots. This is the rule. How can we do this? After that, if variable does not contain any value, will be executed else instruction. So example, how can we use this instruction in our STR program? Here is. So as you see, this is the example of case instruction in STR language. So next instruction is for. You can use this instruction to program repetitive processes. So this is the syntax of this instruction. The part of the structure enclosed in curly brackets is not required. So this is part of the syntax. So these instructions are executed as long as the int var variable, this variable counter, is not greater than end value. This is value. This condition is checked before executing instructions. So the instructions section is not executed if init value is greater than end value. So this is the main algorithm of instruction 4. So whenever instructions are executed, the value of init value is incremented by step size. Step size can take any integer value. By default, the steps is set to 1. For example, this is the program or part of program using instruction 4. This example assumes as that the initial value of var1 is 1. After the loop is completed, this variable will be equal to 32. So this is the example. How can we use this instruction in our step program? Next, a valuable instruction is while. So the while loop can be used just like for the for loop, with the only difference that the exit condition is defined by a Boolean expression. This means that the loop is executed as long as the specified condition is true. So look at the syntax of this instruction. So that means the instructions section runs cyclically until Boolean expression returns true value. So until the Boolean expression is true, these instructions will be run. So if Boolean expression is false at the first iteration, the instructions section won't be executed once. If Boolean expression never takes the value false, the instruction section will run indefinitely. So this is the specific instruction while. So example. In this example, we see that in general the while and repeat loops are more powerful than for because they do not require a predetermined number of iterations. In many cases, you can make do with just these two types of cycles. However, if the number of repetitions is known, it's preferable to use for, since it eliminates the possibility of accidentally falling into an infinite loop. This is the specific instruction while. So, next instruction we call repeat. The repeat loop differs from the while loop in that the first check of the exit condition is performed when the loop has already been executed one time. This means that regardless of the exit condition, the loop is executed at least once. So this is the syntax of this instruction. So the instructions section runs in cycles until Boolean expression returns true. If Boolean expression is true before the first iteration, the instruction section will be executed once. If Boolean expression never takes the value true, the instruction section will run indefinitely. So the programmer must be sure that the loop won't become infinite. To do this, the value of the variable included in the condition must change in the loop body. So for example, by incrementing or decrementing the counters. So this is the example. How can we use it in our step program? So there are some instructions, return and exit, that we use in our step programs. Instruction return. The return statement lets you exit the poll, for example, depending on the some conditions. And instruction exit. If exit occurs in the for, while, and repeat loops, the loop ends regardless of the value of the exit conditions. So this is the last two operators or instructions in ST program, ST language. that we need to use in our program. So now let's look at the process of creating a project in the STL language and the CoDeSys software package. Yes, because in our tutorials we always use the CoDeSys software package. So first we create a new project where we select the type of PO as program. Then we need to select the language in which we will write our program. So it will be the STL language. This is. So after that we have the same program in STL language. Variables are declared as usual in the program in this part of this our window. And the program text itself is written in the field below. Yes, this is the field for programming in STL language. Using the learned syntax of expressions for the STL programming language we talked about in this part of our lecture. So a special feature of the program is that the text must contain at least an empty expression in the form of a symbol semicolon. So in this lecture we learned basic rules and conditions, programming in STL language. So I hope it was useful. So and next lesson in our tutorials we will use these languages for step PLC programming. So see you. Bye bye.